A very good morning, students. Once again, I welcome you all back after the holidays. I hope that you've had a nice and safe vacation. Now, this lecture will be for maths class 10th. As you must remember, already we have started the equation of a straight line as the new chapter, and we had done a few basic things in this particular chapter just before the first unit test. If you remember, we had discussed what is the general format or the general form of a straight line, what are the things like slope or the gradient mean, okay, and then we had learned terms like intercepts that a line makes on the x-axis, on the y-axis. So what are intercepts? Intercepts are the portions or the parts that our line cuts or makes on the axes, whether it be x-axis or it be y-axis, okay. And if you remember, the slope or the gradient of a particular line was represented with the small letter m. If you remember, there was a small letter m which we used to denote for representing the slope of a line, and the formula for m was tan theta, okay. So here is the basic revision of some of the things that we had done. M is equal to tan theta. M is the slope of a line and theta is the angle which that line is making with the right hand side, positive side of the x-axis, okay. So now you see, these are some cases that I have drawn, some diagrams that I have drawn in which I have shown some lines. These are particular cases, so we will get to know what are the particular scenarios that we are going to be dealing with here. Now you see, over here, because of the space limitation, I am not labeling these axes. Obviously, it is understood that this is the x-axis, this is the y-axis in all the four cases. Now, let us have a look at the first case. This is the line that I am talking about, okay. So, as you can see, this particular line in our question, in this particular question, this line that we are dealing with is a line which is running parallel to the x-axis. You can see these arrows. So this line is a line which is parallel to the x-axis. Okay, so if somebody asks you, without giving the angle theta for this particular line, if somebody asks you, what is the slope of this particular line going to be? Okay, now the only information that you need, that you know about this particular line is that it is running parallel to the x-axis, okay. So if two lines are parallel, what is the angle that the two lines are making with each other? Obviously no angle, so the angle is 0, okay. So in this particular case, the theta value is 0 degrees, okay, because theta by definition in the formula m is equal to tan theta. Theta is the angle which the line makes with the right hand positive side of the x-axis, but here there is no angle being made, or the angle is 0, okay. So obviously the slope of this line will become tan of 0, which is 0, okay. So now onwards you will always remember, any line which is running parallel to the x-axis will have a slope 0, okay. Now come to the second part of the diagram, in which you have another line, straight line, but this time it is running parallel to the y-axis, okay. As you can see, this particular line is the line in our question, okay. You can use two arrows to show the line, okay. So this is our line and this is the y-axis, okay. So this time our line is running parallel to the y-axis, okay. So in this case, if somebody asks you, what is the slope of this line going to be? Again, obviously, slope of the line will depend upon theta. So theta, what is the angle theta that this line is making with the positive side of the x-axis? So if you see, this is the theta that we are talking about, okay. So this theta obviously here in this case is 90 degree, okay. So here theta is 90, therefore the slope of this particular line can be written as tan of 90, which is infinity, okay. And this infinity can also be represented as 1 upon 0, okay. So in all equation forms, in all questions, whenever we require the slope of such a particular line, we will represent it as 1 upon 0, okay, because tan 90 is the slope. Here the angle theta is 90, so tan 90 will be infinity. Okay, so these are two cases which you will have to keep in mind, in which the lines are running either parallel to x-axis or parallel to y-axis. Okay, so in one case the slope will be 0, in the other case it will be infinity or 1 upon 0. Now coming to these two cases once again, where this line is running parallel to the x-axis and this line is running parallel to the y-axis, if somebody asks you what is the equation of this line going to be? Till now we were discussing only the slopes. Now we are going to be asked the question, what is the equation of this line going to be? So in such cases it is very easy to find out, because you see this line is running parallel to the x-axis, okay, and from the origin it is at a distance of b. If you can see on the y-axis it is at a distance of b units, okay. Here also it will be at a distance of b units. Here also if you see it will be at a distance of b units. So this particular line simply will have the equation y is equal to b. Okay, y is equal to b is going to be the equation of this particular line which is running parallel to the x-axis at a distance of b units. Okay. Why is this equation going to be y is equal to b straight away? Because if you see, if you take any point on this particular line, any point in this particular line, all these points will always be at a distance of b from the x-axis. Okay, so this is the common thing, this is the thing that is common to all the points on the line. So y is equal to b is the equation of this particular line. Similarly, coming to this particular line which is running parallel to the y-axis this time, if you see, if I make this particular parallel sign, okay, this line in question is now running parallel to the y-axis at a distance of a from the y-axis. Okay, if you see, this distance is a. So here also the distance will be a, here also the distance will be a, everywhere the distance will be a. So here the equation of this line can be written as x is equal to a, because all the points on this particular line will always be at a distance of a units from the y-axis. Okay, so here you see this particular point also you can write, this point is going to be a comma 0. Okay, so this particular line will always have an equation x is equal to a, because it is always at a distance of a units from the y-axis. Okay, so these are some general case scenarios that you will have to keep in mind. Now coming back to what is the main part of this chapter, the different forms of the equations of straight line. Obviously the first form, as you can see, slope-intercept form. This form, slope-intercept form. Slope is m and intercept is c. You have already discussed this. We have already discussed this form and done a few questions also. Y is equal to mx plus c. C is the y-intercept and m is the slope. Okay. Now coming to the second part of the equation of a straight line, you have the point slope form. Okay. Now point slope form, what does that mean? One point will be given to you and the slope will be given to you. Okay, so supposing somebody asks you a question, find the equation of a line which is passing through a given point and having a particular slope. So one point through which the line is passing will be given and the slope of the line will be given, and you will have to form the equation of that line. Okay, so here you see, this is the form of this particular point slope form of the equation of a straight line. Y minus y1 is equal to m in brackets x minus x1. Now this is not so difficult to remember, keeping in mind x1 y1 is the point that is given in the question. Okay, so this point x1, from where will you get? This point y1, from where will you get this? This will be the given point. So this point will be given in the question, and obviously your slope m will also be given in the question. Okay, so just like you memorized this particular form, you will have to memorize this particular form also. Okay, once you memorize this, it will be pretty easy. We'll take up a question here. Find the equation of the line passing through the point this. So as you can see, this is the point that we were talking about, and having a gradient. Now gradient, there is a reason why I have used the word gradient, just to check if you remember that gradient is another name for slope of the line. Okay, so having a slope of 1. Okay, so obviously your slope value is also given, your point is also given. So which form are you going to use? Can you use this form? No, we are going to use the point slope form. Okay, so the point slope form is y minus y1 is equal to mx minus x1. What is our x1 y1? So you can simply write down x1 y1, which is our given point. It is given as 2, 3. Okay, and what is the second information that is given to you? Slope is 1, or the gradient is 1. Okay, so these two informations are given. So simply use y minus y1. Now what is y1? y1 is 3. So y minus 3 is equal to m value is 1. You see, this is the form m. So m value I have put, and you will have x minus x1. What is x1? x1 is 2. Okay, so here you go. Similarly, you can have y minus 3 is equal to, obviously 1 is not going to make any difference. So you are going to have x minus 2. Similarly, in the next step, you can have y is equal to, this minus 3 will go to the right side. So you will have x was already there, and you will have minus 2 plus 3. So that is going to be 1. So this is your final answer. Okay, so this is pretty simple. These are the first two forms of equations that we have studied. One involves the slope and intercept form. So when are you going to use this? When the slope and intercept is given. When are you going to use this form? When when 1 point and obviously the slope is given. Okay, so this is there. Now, so here is the third form of the equation of a straight line. You see the third point, as it says, 2-point form. Okay, so here the important thing to note is 2 point. Okay, so that means 2 points will be given. Which 2 points? The 2 points through which our line is passing. You see, when 2 points through which the line is passing. Which line? The line for which we want the equation. Okay, so the line will be passing through 2 given points. Okay, will be given. 2 points will be given. Okay, so in that case, you see, although this form looks pretty complex, but I'll explain what this particular thing is. You see, y minus y1 is equal to, now this, if you see, this entire thing over here, this particular thing is nothing but the slope when 2 points are given. So if you remember in the previous lecture, I had informed you about the slope of a line passing through the 2 points. So suppose these two are the points through which the line is passing. Okay, so suppose this is the line, this is 1 point and this is another point. These 2 points are there. One is x1, y1, the other one is x2, y2. So what was the slope of such a line? Slope of such a line was y2 minus y1 upon x2 minus x1. Okay, so if you remember this, then this particular form is not difficult at all, because essentially this form is y minus y1 is equal to m. You see, this entire thing is m. Okay, m x minus x1. Okay, obviously x1 y1 and x2 y2, wherever we have written x1 y1 x2 y2, these are the 2 points that will be given in the question. Okay, so now let us have a look at the exact question so that we can understand this format more clearly. You see, a straight line passes through P, which is the first point, and the midpoint of the line joining this and this. So let me complete the question. Find the equation of the line. Find the equation of that line. Okay, so now, just now we studied that this will be a 2-point form, but if you read the question, there are actually 3 points given. So just do not be in a hurry. Try and understand. I have taken up this question just to make it a little more logical. You see, our straight line for which we have to form the equation, that line is passing through P. So number 1, it is very clear that P, this point 1, 4, is one point through which our line is passing. Now, and our line is passing through the midpoint of the line joining this and this. So our line is not actually passing through these 2 points, but it is passing through the midpoint of these 2 points. Okay, so if you see these 2 points, what is the midpoint going to be? So midpoint will be, obviously you can use the midpoint formula. So for the midpoint formula you will have x1 plus x2 by 2. Now this much you will have to remember. This was taught in the 9th standard also. So you see there is a point A and there is a point B. You have to find the midpoint. Okay, so it will become 5 plus 3 by 2, and similarly 1 plus 3 by 2. Okay, so this midpoint becomes 5 plus 3 is 8, divided by 2 will be 4, 3 plus 1 is 4, divided by 2 will be 2. Okay, so after finding the midpoint of these 2 lines, we get this point. Okay, so we can call this point as point Q. So now it is very clear that our straight line is passing through this point and the midpoint, which is this. Okay, so these are the 2 points that we are talking about. Okay, so I will call this point to be x1 y1 now, and I will call this point to be x2 y2. Why am I calling this x1 y1 x2 y2? Because we need these 2 points in this particular form. Okay, so now I'll try to use this 2 point form, because remember we have to find the equation of this line. Okay, so y minus y1. Now what is y1? y1 is 4. So 4 is equal to, now this portion here is m, which is the slope. So you can either take it out separately or you can put the values straight away over here. y2 minus y1. What is y2? y2 is 2 minus y1. What is y1? y1 is 4 upon, what is x2 minus x1? x2 is 4 minus x1 is 1. Okay, and then in brackets you have x minus x1. x1 is 1. Okay, so y minus 4 becomes equal to 2 minus 4 obviously is minus 2 upon 4 minus 1 is going to be 3, x minus 1. Cross multiply, now it is all easy. 3 comes over here, you will have 3y minus 12 is equal to minus 2, x minus 1. If you take minus 2 inside, you will have 3y minus 12 is equal to minus 2x plus 2. Minus 2 into minus 1 is plus 2. Okay, so you will have 3y minus 2x can be taken to the left hand side, it will become plus 2x. This can also be taken to the left hand side, it will become minus. So minus 12 and minus 2 will make it minus 14 equal to 0. This is our final answer or the equation of the required line. Okay? Okay, so let's move on to the next question. Question number 3. Now there are different forms or the types of questions that we will have to see. So we will try and see how many we can do over here. Find the equation of a line passing through this point. So one point is given, okay, and intersecting the line, this line, which is another line on the y-axis. Okay, so let us first try and understand the question before we go on to apply a particular form of an equation. Now this is not a very straightforward question. As you can see, the line is passing through one point. So one point is clear to us. Okay, one point is given to us through which the line is passing. Okay, and intersecting. So our line is intersecting another line. Okay, so intersecting means basically cutting across another line. Where? On the y-axis. So let me just draw a rough diagram for you to understand the situation broadly. Okay, now suppose that these are the two axes that we have. Okay, now where is this point 2, 3 going to be? Somewhere over here. Suppose this is the point 2, 3. Okay, so suppose that this is our line. Okay, This is our line, because our line is passing through this point 2, 3. Okay, and our line is also intersecting another line on the y-axis. So on the y-axis means over here. Okay, so there may be another line, this line, which is intersecting our line. So this is, if I write, this is our line, for which we have to find the equation, and this second line is 2x minus 3y is equal to 6. Suppose something like this. Okay, or obviously this line could go like this also. That's not a big issue. You will have to see which way it goes. So what I'm saying is that this particular line, the second line, can be drawn like this also, no problem. The main point that you have to keep in mind is that our line is intersecting this second line where? On the y-axis. So this point is the intersection point. So if we can find out this intersection point, you will see that we will get 2 points through which our line is passing. Okay, and 2-point form, then we will be able to apply. So this diagram drawing is absolutely not required as a part of the solution to the question, but since this is the beginning, this is the first time we are doing these questions, so always visualizing and drawing the diagram in the rough will help you understand the scenario better. Okay, so now let us go to the solution part of the question. On the y-axis, the x part is always 0. Okay, so this particular point will always have the x part 0 and the y part is not known to us. So we can treat this particular point to be 0, a. Okay, please understand, this has to be very clear in the mind. All the points on the y-axis have x part 0, and similarly all the points on the x-axis have y part 0. Okay, so now this is the second line that was there. Now whenever this line is going to cut the y-axis, that means at that particular y-axis the x part will be 0. So in this equation, put x is equal to 0. So we will get 2 into 0 will be 0 minus 3y is equal to 6. So that means y is equal to 6 upon minus 3, which is going to be minus 2. Okay, so by putting x is equal to 0, I am getting y as minus 2. That means our point is 0, minus 2. Which point? This point, 0, a. So this point, now we can write this point as 0, minus 2. That means now we have two known points. One point we have just calculated, 0, minus 2, which is the point of intersection of these two lines, and the other point was obviously already given. Okay, so 2 points, our 2 points, we will write x1, y1. You can take x1, y1 to be 0, minus 2, this point that we have just calculated, and take the second point as x2, y2, which was already given, so that was 2, 3. So what is this? This is 2-point form. Okay, so we can apply the 2-point form. What is 2-point form? Y minus y1. So you see, y minus of minus 2 will make it plus 2 equal to, now if you remember, obviously over here it was y2 minus y1. So y2 is 3 minus y1. y1 is already minus 2, so minus plus 2 upon x2 minus x1. So 2 minus 0 is going to be 2. Okay, and then x minus x1. x1 over here is 0. Okay, so this is the equation. Okay, so in case you are wondering how we wrote this, obviously you will have to have the 2-point form in the mind. So y2 minus y1 upon x2 minus x1 and x minus x1. Okay, so this is the 2-point form that I have used in this particular question. Obviously, why have I used this 2-point form? Is because 2 points are given. Okay, so we have y plus 2 equal to, now it is just calculation, 5 upon 2, and this is x minus 0 will be simply x. So 2 goes to this side, you will have 2y plus 4 is equal to 5x. Okay, this is your equation. If you want to take the x also on the same side, you can have 2y minus 5x plus 4 is equal to 0. Whichever way you want to put it. Okay, so this is the equation of this particular line. Now let us continue with the next question. Find the equation of a line passing through this point. So again one point is given and making positive equal intercepts on the axes. Okay, so once again you cannot directly apply any particular form because 2 points are not given, 1 point and slope is not given. Okay, intercept word has been used, so we will have to make use of that. So let us understand our question once again by drawing a rough sketch. Okay, so suppose these are the two axes that we have. Okay, the x-axis and the y-axis. Find the equation of our line which is passing through the given point 3, 2. So we will write the first point is already given as 3, 2 and our line is making positive equal intercepts on the axes. Axes is the plural word, that means on both axes. Okay, so the two important things to note here are positive. Intercepts are positive. That means on the x-axis the line is cutting on the right side and on the y-axis the line is cutting above. So I can draw something like this. Okay, if you see, this is a line that is cutting x-axis also on the positive side and y-axis also on the upward side, which is the positive side. Okay, I hope you remember that this is plus x, this is minus x, this is minus y and this is plus y. Okay, so these two intercepts, this intercept and this intercept, they are positive, number one. Number two, they are equal. That means if this is A, this is also going to be A. Obviously this is origin. Okay, so if both these two intercepts are AA, that means this point immediately, if you call that as P, it will become A, 0. Why A, 0? Because y part on x-axis will always be 0. Similarly, this particular point over here, if you call that point to be Q, okay, this point will become 0, A. Here the x part will be 0 because this point is on the y-axis. On y-axis, just now in the previous question we discussed, all points on the y-axis will have their x part 0. All points on the x-axis will have their y part 0. Okay, so P and Q are A, 0 and 0, A respectively. Okay, and obviously our line is also passing through a point 3, 2, so that 3, 2 point can be somewhere over here. Okay, so this point is 3, 2. Okay, so this diagram will actually give you help you visualize what exactly is the situation. Okay, so theoretically now we know only one point. We have to get another point. If we get the second point in terms of values, then we will be able to apply the 2-point form to find out the equation. Okay, so let's see how we can find out the second point that we have in this question. Okay, so if we take the equation of line PQ, this is the point P, A, 0 and this is the point Q, 0, A. So equation of the line PQ will be what? It will be y minus y1. So let me say that this is my point x1, y1 and this is my point x2, y2. Okay, so y minus y1. y1 is 0. Okay, equal to, now y2 minus y1. So y2 is A, y1 is 0. So A minus 0 upon x2 minus x1. So that will be 0 minus A into x minus x1. x1 is A. Again, this is the 2-point form that I am using What are the 2 points that I have taken? I have taken P and Q. So obviously by using this, am I going to get the equation in the exact form, in the final form? No, because I don't know the value of A yet. Okay, so let me first simplify this. Y minus 0 is Y equal to A minus 0 is A, 0 minus A is minus A, and you have X minus A here. A and A gets cancelled, so you get Y is equal to minus X plus A. I have taken this minus sign inside the bracket, so Y is equal to minus X plus A is my equation for our line PQ. But this is not the final answer because we have to find the value of A. So here is the need or the requirement of this particular point that was given to us. This is the equation of our line. And is our line passing through a 3, 2? Yes, it is passing through 3, 2. So that 3.2 should satisfy this equation. That means we should be able to put the values of put the value of the coordinate. So over here Y value is going to be 2. So 2 is equal to minus of X. X is 3. So minus of 3 plus A. So A becomes minus 3 goes to the other side. We have the value of A as 5. Okay, so the moment we get the value of A as 5 in equation 1, we can simply put it back. So we will have Y is equal to minus X plus 5, or you can take minus X to the left side, it will become plus X. X plus Y is equal to 5 is my final answer. Okay, so how have we solved this particular question? 1 point was given and the information was given that it is cutting positive equal intercepts on the axis. So those positive intercepts we will take, assume to be AA, and then we will form a general equation, then satisfy the given point, we will get the final answer. Okay. Okay, so this is another question, probably a little lengthier, and it has a number of parts to it. Okay, so let us see if we can solve this. 3 vertices of a parallelogram taken in order are this, this and this. Okay, so obviously in a parallelogram there are 4 vertices overall, 3 of which are given in serial order. Okay, so you can see I have drawn a rough diagram. A, this vertex, B, C. These 3 vertices taken in an anti-clockwise order. You could have taken it clockwise also. A, B, C, 3 points are given. The 4th vertex or the 4th corner is not given. So I am assuming it to be AB. Okay. What is the question? There are 3 parts to this particular question. We have to find number 1, 4th vertex D, obviously this vertex. Then the length of the diagonal BD, this diagonal BD, length of it. And then the third part will be equation of the side AB, this side, this side. Okay, so this side obviously is a straight line. Okay, AB, for which 2 points are given. Okay, so let us first see whether we can solve the first part that is given, which is that has been asked, which is the 4th vertex D. Okay, so if you apply a little bit of mind to it, you will obviously have to notice that this question is about a parallelogram. So for parallelogram there are certain properties that exist. We will have to make use of those properties. Okay, one such property is that the diagonals of any parallelogram bisect each other. Okay, so that means this part and this part is going to be same. Similarly, this part and this part is also going to be equal to each other, because these are the 2 diagonals, they are intersecting or bisecting each other into 2 equal halves. Okay, so this point over here, if we call that point to be M, this point will be the midpoint of these 2 also and these 2 also. Am I correct or not? Have a look at it carefully. You see, these are the 4 points or the 4 vertices of a parallelogram. These are the 2 diagonals. Diagonals of a parallelogram bisect each other. So that means they break each other into 2 equal halves. Okay, so obviously M becomes the midpoint. So for calculating m, you see, I am first going to take m as the midpoint of AC, because I know A also, I know C also. Okay, so m, which is the midpoint, can be written as the midpoint of A and C. So x1 plus x2, which is 3 plus 3 by 2. Similarly, the y coordinate will be 6 plus 2 by 2. So my point M will become 3 plus 3 is 6 divided by 2 will give me a 3, and 6 plus 2 8 divided by 2 will give me value 4. So the midpoint M is 3, 4. Now we know the point M, which is 3, 4. Okay. Now we can use this particular information to find out D also, because now M value, which has been found out, is also the midpoint of D and B. Okay, so I can write, since M is the midpoint of B and D also. Okay, so therefore we can write down 3, which is this 3, is the midpoint. So 5 plus A, you have A plus 5 by 2, and similarly the y coordinate, which is 4, is also going to be found out with the help of the midpoint formula for these two. So B plus 10 by 2. Okay, so 2 3s are 6 is equal to A plus 5, so A becomes 1. Similarly over here, this goes this side, B plus 10, so B becomes minus 2. Okay, so we have found out the value of A, we have found out the value of B, so I can simply write the answer to the first part, fourth vertex D, is 1, minus 2. Okay, so as far as the first part of the question was concerned, there is nothing to be used from the equation of a straight line. Okay, this is all pure coordinate geometry. The midpoint formula has been used. Okay, now coming to the second part of the question, which is the length of the diagonal BD. Now we know the value of D, so I can simply erase this AB part and I can put 1, minus 2 over here. So now I know B obviously was already given, D also now I know. So length of the diagonal BD, obviously again here nothing from the equation of a straight line is to be used. I am simply going to use the distance formula. So again you will have to remember the formula. Distance formula was taught in the 9th standard, if you remember. So the formula was x2 minus x1 whole square plus y2 minus y1 whole square. So if you remember, I am going to write it down once again. x2 minus x1 whole square plus y2 minus y1 whole square and under root. So you can choose any point to be x1 y1, any point to be x2 y2. So I am going to simply use this point as x1 y1 and I am going to use this point as x2 y2. Okay, so just put the values over here. x2 minus x1, x2 is 5, x1 is 1, so 5 minus 1 square plus y2 minus y1, so y2 is 10 minus y1 is minus 2, so minus minus becomes plus square. So simply over here you can have 5 minus 1 is 4, 4 square is 16 plus 10 plus 2 is 12, 12 square is 144. So you are going to get root 1, 6, 4, 10, 4 and 1, 5 and 1, 6. Root 160. So obviously this can be done further by factorization. You can have 4 is 16 into 10. So 1 4 gets paired. 4 comes out. So you will have 4 root 10 units. Okay, 4 root 10 units. Okay, so this obviously made use of the distance formula. Now coming to the third and the last part of the question is, as you can see, equation of the side AB has been asked. So this part of the question relates to the current chapter that we are doing. So I've just erased a few lines to create a little more space. We are going to deal with the third and the last part, equation of the side AB. This is A, this is B. These are two different points. Both points are given to us, so we can easily use the 2-point form. Okay, so in this 2-point form, this time around I am going to use this point as my x1 y1 and this point as x2 y2. Okay, so equation of side AB, you can see y minus, now again you must remember the exact form, y minus y1, which is 6, equal to, then we will have y2 minus y1, so 10 minus 6 at the top, and x2 minus x1, so 5 minus 3 at the bottom, and x minus x1, x1 is 3. Okay, so y minus 6 is equal to 10 minus 6 is 4 upon 5 minus 3 is 2, x minus 3. 2 2s are 4, this gets cancelled out, so you have y minus 6. Okay, y minus 6 is equal to, this 2 goes inside, you have 2x minus 6. So finally you have y is equal to 2x, and minus 6 and minus 6 gets cancelled. So you have y is equal to 2x is the final equation of the line AB, or the side AB, you can say that. Okay, so this is what we have. So this was all as far as this lecture was concerned. In the next lecture we will discuss the conditions of the perpendicularity of two lines and the condition which is prevalent when we have two lines running parallel to each other. Okay, so there will be different cases of two parallel lines running along, and then you will have cases in which there are two different lines which are intersecting each other at 90 degrees. Okay, so all those things we will discuss. I hope now you will be able to solve most of the questions in the very first exercise. Please go home, and you're obviously at home, so please go through all the different questions once again that we have solved here, and I'm sure you'll be able to do the remaining.